All right, here are solutions for perfect problem 2 from Math 243. I'm given a bunch of data in the form of a stem and leaf plot, and then asked to do a bunch of stuff with it. So first you need to be able to look at this and tell what the data is, and then calculate a bunch of stuff. We're going to use our calculator a bunch, so you'll first want to put this data into your calculator. I won't spend much time there since I think by now you get the hang of that, but basically what you do is you hit stat and then go into the edit menu and then type in all these observations one by one. We've already done that. Note that, well, you have to be able to read a stem and leaf plot. So this 4 represents an observation of 64. This 0, 70. This 2, 72, and so on. That's all these values here. And then for part 1, it wants us to create a 5-number summary. What you need to know about a 5-number summary is kind of what it is. So maybe 5-number summary. And like the name implies, it's 5 numbers that summarize the data. Specifically, it's the minimum value, the first quartile, the median, the third quartile, and the maximum value. And you could figure these all out by hand, or you could take advantage of this calculator that we got sitting over here and have it figure out these things for us. So what you do, you hit the stat button, and then go over to calc. And then one variable statistics will be the function that determines all this stuff. So hit enter. A good habit to get into is telling it what list your data's in. Mine's in L1. Although if you leave that off, it'll default to L1. So in this case, it wouldn't make a difference. Hit enter, it gives you this. You don't see any of these here. And that's because these are the last 5 things listed in this output. You have to scroll down. That's what this little arrow indicates, is that there's more stuff down here. Scroll down, and they appear. The minimum value was 64, which looks right if you look at this data. The first quartile was 76. The median value was 82.5. The third quartile was 92.5. And finally, the maximum value was 145. There's my 5-number summary. Number 2, maybe a little bit more interesting, asks you about outliers. Outliers are observations that are not between our fences. Between the fences. You could say they lie outside the fences. Sure. Okay, so which of these observations are outside of the fences? I don't know, because I don't know what the fences are. So we got to figure out the fences. There's a formula for the fences. The upper fence is equal to the third quartile plus 1.5 times the interquartile range. The lower fence, similar, except now it's the first quartile minus 1.5 times the interquartile range. We have Q3 and Q1. We figured that out up here. We don't know IQR yet, the interquartile range. But we could figure it out because it's just the difference in the third and first quartiles. So since Q3 was 92.5 and Q1 is 76, we subtract those two values and get, what, 16.5, I think, as our interquartile range. So what that's telling me is that my upper fence is, I'm going to run out of room. I guess I'll just write the answer. My upper fence is Q3, which is 92.5, 92.5, plus 1.5 times my interquartile range, which is 16.5. 92.5 plus 1.5 times 16.5. My order of operations, I'll do this multiplication first and then addition, so I don't need to worry about parentheses or anything. I hit enter, and I get that my upper fence is 117.25. I want to do a very similar calculation. I'm going to hit second and then enter. That'll pull up that last entry that I just did, because the formula is so similar, except now it's Q1, which was 76. Wrong button. 76, and then instead of plus, it's minus. 76 minus 1.5 times the interquartile range gives me 51.25. So these are my fences. Everything from 51.25 to 117.25. is within my fences. Note 128 and 145 aren't within, between, how about? Maybe that's more clear. Fences, so they're outliers. I guess that's it. Number 3, sketch a box plot of the data. Maybe I'll go to green now. Box plot of the data, you can do it either by hand or by your calculator. I'm going to use my calculator to already have all this data in here. The way you get a box plot, first put the data in, all right, it's still in there, and then it's a plot, so go up to stat plots, second y equals. And then we'll just go into the first one here. First, make sure you turn it on. Second, select the one that looks like a box plot. You're like, 2 of them do. This one does and this one does. Yeah, choose the first one. Choose this guy right here. And then what list is your data in? Mine's in L1. Frequency, that's just a default. Always leave it as 1. And then mark, that's just saying if you have any outliers, they're going to put a little mark to represent the outliers. What mark do you want to use? I don't know why they give you this as an option. Does it really matter? Whatever. My outliers are going to be, I'm going to switch it. Why not? I'm going to use this fancy little mark because I feel like using a different one. You use whatever the hell you want. And then you want to view this thing. You could just take graph. I like to do zoom and then zoom stat to have, my window might have been shaped strangely from a previous problem. So zoom stat will tell my calculator, zoom in on the statistics part of what we're doing. Hit enter. Here's something that pops up. My answer is going to look, roughly speaking, like, try my best to copy that thing more or less to scale. A little bit bigger, and then this is a little longer. And I get these 2 outliers out here, one somewhere in here and one somewhere in here. It's good to put a little scale on this thing. Typically the way you do it is kind of putting an axis below the plot. And so we can figure out where all these points are. This was our minimum value at 64. And then this was our first quartile, which is 76. And this was our median, which was 82.5. And then our third quartile was 92.5. This labeling of all these points is not something you need to do. I just think it's a good idea. I think it makes it get more information from the picture. And then this is not our maximum value. It's our maximum value that is not an outlier. It's 115. If you look up here, this was the largest observation that wasn't an outlier because 128 and 145 were outliers. As we were verifying what we figured out in part 2. Box plot looks like this. Typically what you do is you kind of label your axis here. So in my picture, 60, 70. Yeah, this is going to be a horrible picture. Let me try again. Let's put 60 here, 70 here, 80 here, 90 there. I'm trying my best to make this kind of to scale. 100, 110, 120. Maybe it would have been a good idea to do this before I labeled all the points. 130, 140, and 150. I would call this good enough as far as my box plot. I think I just had to draw one. Sketch a box plot of the data. All right, I just did it. Part 4. Back to blue, I suppose. Part 4 says, to win an award, kids must grow a pumpkin. I guess these are the weights of pumpkins. It probably says that up top. In the 80th percentile. Calculate the 80th percentile of your data. All right, I can do that. What you need to know is the percentile formula. The kth percentile is k divided by 100 times n plus 1. So the 80th, it's that observation. So the 80th percentile would be a divided by 100 times n plus 1. N is 20, so we go over here and we say 80 divided by 100 times 21, n plus 1, you get 16.8. What is my 16.8 observation? Well, I don't have a 16.8 observation. I have a 16th observation in my list when I ordered them from smallest to greatest, and a 17th. 16.8 is somewhere between 16 and 17. I'll just average 16 and 17 and be done with it. See, this was the 20th, so this was the 19th, this was the 18th, this was the 17th, 20, 19, 18, 17, 16. So 16 was 95, 101. My 16th observation, my 17th observation. If I average the two of those out, I get 98, which is the 80th percentile. In other words, if you want to be in the 80th percentile, you better grow a pumpkin that weighs at least 98 pounds. I don't know if that's big or not. It sounds big to me. Finally, calculate the mean and the standard deviation. Then determine the z-score for the 100-pound pumpkin. Okay. Where the hell am I going to do this? Maybe up top. So here's number 5. Go to stat, go to calc, go to one variable statistics. We've been here before. Tell it your data is in L1. Pulls this menu back up. So I know that x bar equals 88. This is my sample average. Calculate the mean and the standard deviation. Maybe I should have said of the sample, although that's all you have is the sample. And S is equal to 20 point, maybe I should say is approximately equal to 20 points, I don't know, 316. It's more than enough decimal places. So if I want to calculate my z-score is a fraction, or the formula for it is a fraction. The top I do my observation, so the 100-pound pumpkin, minus my mean, 88, divided by my standard deviation. So 100 minus 88 is 12, and 12 divided by 20, I guess 20.316 if I want to be a little bit more precise. 20.316 is 0.59. It's my z-score. What that means is that my 100-pound pumpkin is 0.59 standard deviations above the mean, which will have more meaning as we get further into this class. 6 says do it again. Why? I don't know. This might have been a bad idea. Do it again, except now do it without the outliers. So go into your data. You don't want to use all your data. You want to get rid of the last two, because the last two we determined to be outliers. Right? We determined 145 was an outlier, so I'm going to delete that. And we determined 128 was an outlier, so I'm going to delete that. And now on this new L1, I'm going to do one variable statistics again. Stat, calc, one variable statistics, L1. It'll give me a new mean and a new standard deviation. It'll tell me x bar equals 82.6 approximately. And that S is equal to 12.054 approximately. So if I want to calculate my new z-score, instead of being 100 minus 88, it would be 100 minus 82.6. And instead of dividing by 20.316, I'm going to divide by 12.054. A couple observations you might want to make. By getting rid of those outliers, my mean decreased significantly. Went from 88 down to 82. I got rid of a bunch of big pumpkins, so my average is a lot smaller now. My standard deviation also got a lot smaller, because those outliers were the ones that were way spread out from the rest of the data. With those gone, my data is less spread out. So I got to do 100 minus 82.6, which is 17.4. And then take that number and divide it by 12.054. And get 1.44 approximately. So what that tells us is that if you get rid of those outliers, the z-score is significantly higher. So with those outliers in there, I'm only 0.59 standard deviations above the mean. That 100-pound pumpkin is anyways. But if you get rid of those outliers, the mean is smaller and the standard deviation is smaller. So this observation of 100 is now more standard deviations above the mean. I think that's everything. So I guess I'll end the video here.